Hello, in this video we're going to cover implementing the AI system into our tic-tac-toe game, because if we launch our game, what we've got a splash screen, we've got a main menu, the main menu takes you to the game screen, and on the game screen we have a grid system which we can place pieces on. We've got an automatic sign in to Game Center, and you'll have the equivalent for Google Play services if you've implemented that. If I click play, get a grid, I can start placing pieces, cool animations, and there is a win condition and I can no longer place any pieces. But at the moment we don't want to play against each other, we want AI in there. That's what we're going to be implementing in this video. So first of all, go to your definitions file and we need to add a few extra definitions. So the first two we need to add right here, and it's going to be a define for the player piece. So player underscore piece underscore x, the player piece, and this is going to be x underscore piece. You can change it around if you want it to be a circle. And we need one for the AI piece, and this is going to be circle underscore piece, so piece like so. And there's two more states that we need to add. We need a state for when the AI is placing a piece. You might be thinking, oh, the AI realistically should be instantaneous. One, there may be a delay, and two, because of animation as well, it won't be straight away. There will be a bit of a delay, hence why we need a state to prevent you or prevent something else occurring while the AI is actually playing. Then we need a state for draw, because if you draw in the game at the moment, nothing happens. There's nothing to handle that situation. So once you've got these states and pieces sorted, what we're going to do is create a couple of new files. So if I right click, go to the Finder, I always like just getting an existing file, duplicating it and renaming it accordingly. This is going to be called ai.h. As you can tell, this is going to be the artificial intelligence files. And let's scroll back, we just need to include these into our project. Obviously you include them however you need to, depending on what IDE you're using. Don't need to copy it, finish, and we got AI. And what I'm going to do is literally just get rid of all of the contents, and we'll be writing all of this out from scratch. So for the header file, we are going to put a hash pragma once. Then we're going to do include Cocos2d-x. Going to include the C++ vector class, because we're going to be using vectors. And we're going to do hash include array as well. So the class, I think you can guess what it's going to be called, AI. And in the public, there's going to be two methods. First one is going to be the constructor, and this is going to be an int player piece. So this will be when initialized, the player piece will be passed in, so the AI knows essentially what the player piece is and then essentially what its piece is. We're going to do void place piece. So this is the only public method that allows the AI to place a piece. So first of all, we need to pass in some parameters. We need to pass in the actual grid array. So we're gonna put this as an int, and we are passing it in such a way that allows us to modify the original values. So remember, it's a 3x3 array. We're also going to pass in a Cocos2d: sprite, and this is going to be grid pieces 3x3, and we need an int game state as well, so the AI knows exactly what state the game is in. Private, and there are two methods here. The first one is void check section, so this is going to allow us to check a particular section and handle it accordingly. So for this we need to put int x1, int y1, int x2, int y2, then int x and int y. We need an into check piece to check, so obviously what piece we're checking. And now we need to pass in our grid as well, just exactly how we've done up here, so we can copy and paste this. Once you've done that, we need to pass in the grid pieces sprite array as well, because obviously if we're placing a piece, we need to be able to update the grid accordingly. Let me just create some empty lines so I can easily scroll up and down. I'm going to put a void, and this is going to be check if piece is empty, because obviously we don't want to be able to place a piece if it's not empty. This is going to be int x, int y. I'll do this as uppercase, x and int y, and we are passing in the grid array the same way we did before, and we're passing in the grid pieces array as well, so we can copy and paste this from here like so. All good. And now we need a few variables. We need int AI piece, int player piece, which we're passing in. We'll calculate the AI piece based on the player piece. And we need a vector, and it's going to be a vector of arrays, and the array is going to be of int with 6 items, and this is going to be the check match vector. Some of this may sound a bit confusing at the moment. Don't worry, as we code it very soon, we'll explain what each one of these functions, these variables, are all used for. So I'll put a semicolon there. If we go to our ai.cpp file, we can now start coding this bad boy. So what we want to do is do hash include ai.h, hash include definitions.h, and we need to do a hash include iostream. We're going to use the namespace std, probably just make it easier. You could do that within the header file as well. We're going to have a constructor, so ai : ai, and remember this takes in a player piece, which is an integer, so int player piece. Okay, and now we need to do this player piece equal the player piece that we passed in, and what we're going to do is check if circle_piece equals player piece. If it does, then AI piece equals x_piece, and otherwise AI is the circle piece. So circle_piece, very simple code at the moment. And now what we're going to do is call the check match vector. So we're going to do check match vector dot pushback, and you know what I'm actually going to do is open up my web browser and go to GitHub, And the reason I'm going to go to GitHub is just to copy and paste the check match vector code. There's quite a few lines that are very, very similar, and we'll explain what each one of those does. So if I go here, so I just want all of this. So we're just doing a bunch of checks when we are constructing our player, and we'll be implementing this method very, very soon. So we'll actually explain it when we implement the method. So for now, let's just move on to place piece. So what we're going to do is do void AI place piece. So void, it'll probably be easier if I just copy and paste it from here. Copy and paste that. And if I do AI : and what we're going to do is do try for the catch will be int error. I like this to be on a separate line. And what we're going to do in here, we're going to first check if AI can actually win, because if it can, then that is the piece that it should be placing. By definition, that is obviously the goal. It is winning for the AI. So for int I equals 0, while I is less than check match vector dot size. So what we've actually done here is passed on the order of all of our checks. So we would be checking essentially each individual different combination that the AI can take, and this is based on certain tic-tac-toe rules. So instead of just placing a piece for the AI in the first place, there is an empty space, or in any empty space there are, certain rules, certain combinations which are best, and as a result we'll be checking these. First of all, we obviously want to check if we can actually win. If we can, then we would obviously use whichever particular combination works for that. If not, then we'll be using the first combination that we can actually place a piece within. So we need the size, but we're going to iterate over it. Now we're going to do I++. Now we're going to do check section. And for the check section, it is going to be check match vector, check match vector I 0, and we need to copy and paste this. We'll change this to a 1, change this to a 2, change this to a 3, 4, 5, so 1, 0, 1, 2, 3, 4, and 5. Now we need to specify the player piece, and we're going to be specifying the grid array and also the grid pieces. So like so, this check section, we obviously haven't implemented it yet, but we will be very, very soon. Actually, my bad, we're not passing in the player piece, we're passing in the AI piece, because obviously that's the piece we want to place. So now we need to do something similar to check if the player can win. So if we could actually just copy and paste this and check if player can win, because obviously the highest priority is even if the player can win, but if the AI can win by placing one piece, then you would place a piece there. If the player can win, then you need to block the player So that is the sort of the second precedence in the game logic. Now, if none of these conditions are met, so if we can't win or the player can't win, then we can just place a piece in another space, but there's still some logic here. The first thing we would want to do is check if piece is, well, empty. So we want to check if the center piece is empty. So check if piece is empty. So the piece that we're checking is 1, 1, which is the center piece. We need to pass in the grid array. We need to pass in the grid pieces, sprite array. Now, if the center is not empty, what we need to do is check if the corners are empty. And as you are well aware, there are 4 corners. Corners are empty. So the corners are 0, 2, 2, 2, 0, 0, and 2, 0. And if one of the corners aren't empty, then basically check for any other space. So if I were to copy and paste this, check for any other space. So this is going to be a 1, 2, 0, 1. If you want to change the order of these checks, obviously whichever first one is met, whether it's a center, a corner, or any one of these, it will place the piece in there. So you can easily change your game logic very, very easily. And now what we need to do is change the game state by doing asterisk game state equals state underscore plane. So the user can play again because we have well placed our piece. And now what we need to do is check section. So we will go here, actually copy, oh my bad, that should be std not str. Copy and paste these two methods. And we need to have AI colon colon, AI colon colon. So for checking a particular section, we need to check if 2 pieces match. So we need to do if asterisk grid array x1 y1 is equal to the piece to check, and then we essentially want to do the same condition but for y2 and x2. So copy and paste this. So change this to y2, x2, and now in here, okay, seems like we're missing some sort of bracket, I believe. No, that don't look right either. Ah, I'll see what I've done here. There should be a closing bracket here. Should be a closing bracket here. No, that's still the. Getting my brackets mixed up. Should be one closing one there. And a closing one there. So now, should not have any errors. In here, we need to check if there is an empty piece where we are trying to place our piece. So for grid array, so this is X, so this is essentially the matching one. This is the one we would want to complete the set with, whether that's if the player's won or not won. Okay, did I not put uppercase H? I'll put lowercase h for this one, so I'll just put lowercase x and y. And now we need to obviously place the piece here. So I'm literally going to copy and paste this. Again, I messed up the brackets. Literally going to copy and paste this here. And this will be equal to the AI piece. I'm going to put grid pieces, X and Y. And we need to set the texture. And the texture is going to be circle underscore file path and we need to set it to be invisible, so grid pieces X Y set visible equaling true. And now we need to run an action to fade it in. So we're going to do grid pieces X Y run action, and the action we're going to run is a Cocos2d fade in, and this is merely going to take the parameter of time, which is piece underscore fading time. See, that's the great thing about having definition or some sort of settings file that allows us to keep the animations universal. We're going to do throw -1, and the reason we're throwing anything, though we haven't hit an error, is just our way of emitting the rest of the code. So once we've actually done check section. Okay, so assuming that check section has essentially failed and there's no place to put the piece to either win or block the player, we need to check if a piece is empty and place a piece there. So what we need to do is we can actually copy and paste quite a bit of the code. Copy and paste this, move down. So we need to check if empty piece is equal to X and Y, or I'll put this one as uppercase X and uppercase Y. We need to put an AI piece there. We need to set the texture as well. We need to set it to be visible. And we need to run the action. And that is it. So the code is very, very similar. I'm going to throw -2. And this just allows us to handle each different throw differently if we want to. We don't want to, but if you wanted to do something, maybe you wanted to play some sort of separate animation or a separate sound effect or record something separately, unlock an achievement maybe, you can easily do that now within the catch. But that is it for the AI class. Not too difficult, not too difficult to get your head around. So now we got a few changes to make in the game scene. So if you go to the game scene, first of all, we need to do hash include AI.h. We need to scroll down and create an AI object, which is going to be a pointer. And this is going to be AI. Now if we go to our game scene.cpp, we need to initialize it. And we'll just initialize it after we set the piece. But instead of setting it to X piece, we're going to update this so this has player piece now. Because remember, we did do a few changes in the event. In the definition file. So we're just going to put after this AI equals new AI : AI, and we are merely passing in the turn like so. We are almost done. So if we keep scrolling down, there's a few more changes that we need to make. Initiating the grid rectangles, not a problem. Initiating the grid pieces, not a problem. Checking and placing a piece, that looks a-okay to me, so we can just leave that as it is. So if we keep scrolling down, so in the check win section, after we've checked for us being able to win. So if the player can win, we need to check if, well, the AI can win. So if state1 doesn't equal game state, that means the player hasn't won, and we're going to do game state equals state underscore AI playing, so the AI is now playing. I'm going to do AI place piece. So the AI is going to try and place a piece. We're passing in the grid array reference. We're passing in the grid pieces. We're passing in the reference to the game state. Because obviously we want to be able to modify the original values. And what we need to do is copy and paste all of this, because we're going to be checking if the AI has won. The only difference is we are actually going to be passing in the AI piece and the player piece as well, because at the moment when we check for a particular win, we're just checking for the user. So we need to update this so it does int piece to check. We need to update this in the header file. So if I go to check 3 pieces for match, paste that here, and we'll update this code when we need to in a moment. So up here, what we need to do is pass in the player piece every single time. So player piece, oopsie daisy, went all the way down. Okay, now for this we need to pass in the AI underscore piece. So now that we've passed in the AI piece, that's all good for the AI's turn. We need to now check if it's a draw. So what we're going to do is actually, let's remove all of this code, because we're going to be reworking quite a bit of this. We're going to do a variable called empty num. This is going to be equal to 9. And we are going to loop over our grid array. So for int x equals 0, while x is less than 3, x plus plus. We're going to do the same for the y coordinate. So all simple stuff that we've already covered. This allows us to iterate over our 2D array. So we're going to check if there isn't an empty piece in a particular section. So grid array, x and y. If there isn't, that means there's already a piece there, and we need to do empty num minus minus. So if this is actually 0 after we've looped through it, then the game is a draw. You could go the other way and set this to 0, and if there is an empty piece there, then increment it. Whichever way is fine. I've just chosen this method. I'm going to put if 0 equals empty num, then game state equals state underscore draw. And what I'm going to do, just for the purpose of testing, I'm going to see out the game state so we can see what state is occurring after every single move. And now if we go to, actually, what does that not like? Okay, this doesn't like a few things. Expected expression. Okay, game state equals state to draw. I don't see what's wrong with that. If I build it, expected expression. So, what game state here? We're setting it here. Unless, let's go to the definition of state draw. I did not put a particular state number, hence why it gave us an error. So I'm just going to put 92. Go to game.cpp, and now no member name cout in namespace std. I need to include the IO stream. Okay, so the game state is now going to be consoled out, and if we scroll down, so we need to modify the check free pieces and match method. So instead of doing if turn equals x1, y1, and if it equals x2 and y2, what we are actually going to do is if it equals the piece to check. So we can update this accordingly. Everything else should be okay, apart from a couple of things. We need to change this to piece to check. If we just keep scrolling down, obviously we're just placing the winning pieces now. That looks very good. The only other thing we need to do, we're not going to set the game state equal to 1 because it will depend on, well, what piece we were checking for. Or player, where is the player or the AI? So we need to do player piece equals to piece to check. If it's the player piece, then the game state equals state underscore 1. Else game state equals state underscore lose. So now we are actually ready to run this code. Hopefully we don't get any errors. It looks like we don't. And now we should be able to test our AI very, very soon. So it's just building it into our simulator. It should run. Okay, it's running now. We can just close out of Game Center. So cancel. So if I click run, place a piece here. Okay, placed one in the middle. I'm going to place one here. It's blocked me. So, okay. What should I do? I'm going to place a piece. If I place a piece here, I will block the AI, and then by definition they'll just go to a corner. But if I place a piece here, for example, they could block me, but it would be stupid to block me because they could win. So this will be a good test. And as you can see, it has worked. We can't place anything, and now we have a fully functioning AI. At the moment, yes, we have an AI system that actually works, but there's no prompt to the user. Yes, we've got this printing out what particular state the game is in, but we, as the user, don't have a way of actually going back to the game and replaying it. We don't want to have to shut down the game every single time we want to play it. So in the next video, we're going to be handling game over, and we'll be allowing the user to be able to replay their game. So that's it for this video. We covered AI. If you have any questions, feel free to post them on my education platform, sonarlearning.co.uk, or just communicate however you feel comfortable. All the links for the source code will be available. Feel free to check that out. And as usual, thank you for watching, and I hope you have a great day.